Okay. I'm testing two cards, a 420 megahertz Wi-Fi-like device. It's broadband, and it ostensibly should work at least 1 megabit per second, hopefully better. I've done this test before, and from here to a place called Sunny's Place, and we were able to get 2.5 megabits per second, and the download is about 300 tabs from Singapore, and equivalently the Zaggle Communications card from Canada to see which works better, so we can make recommendations. And I suspect they're both going to work equally well. The advantages is from Canada that have a U.S. distributor, so it's just a matter of getting a UPS, not a problem.
So what are the two locations that we're going to be operating from today?
One location is the patio here next to the Pollock dining room of the Skyline Lodge Resort. There's a very nice patio, and it just so happens there's a clear view to this gap in the, what's the name of that mountain range?
Massanutten.
Massanutten, 10 times in a row, Massanutten. So that's Route 211, and at halfway up the mountain is a restaurant with a parking lot called Sunny's Place, and I've been there before. And then higher up, it looks like there's a place where I can get off the road and try it on top of the ridge. And if that doesn't work, we'll just downgrade back the mountain.
So what are what's the distance between these 2 points?
13 miles. Oh yes, thank you. 13 miles, or 12.8 to be exact.
And so we are going to now. The two things we're looking for today is signal quality and
speed.
And speed.
Because faster is better.
Okay. Well, we're going to continue this once we get the equipment set up.
Right.
Thank you. So here is a view from the overlook, right? So Sunny's Place is about 13 miles from here, through that notch in the trees, and so it's basically line of sight. So for today's A/B test between two mini PCI data cards for broadband communications in radio, we are testing two vendors. One is Zaggle, and then the other one is Doodle Labs.
It's related. It's Wi-Fi like.
Yeah.
Right. On 420.
Right. It's a packet. It's a packet.
Well, it's TCP/IP. It's imagine wireless networking,
yeah,
but on 420 instead of 2.4 gigahertz. In fact, the routers don't know anything about ham radio. Standard generic routers. In fact, where's a router? Here's a router. Yeah.
So you use kind of a transverter, or how do you?
Yes. The short answer is yes. This is from Doodle Labs.
Do you mind if I video you? Do you
Not
mind?
at all. Not at all.
This is from Singapore, Doodle Labs. They've taken the Atheros Wi-Fi chipset for 2.4 gigahertz and then added a down transverter.
I see.
Down converter, down transverter. And then you have a pigtail for 420. Actually, this router, this is from Ubiquiti, big manufacturer, and this is a discontinued product. It's called the Router Station Pro. So it's got local area, wide area, and I've configured it so you actually have four connected together. But the nice thing is power over Ethernet. Longer than my arm, but it'll keep us busy for the next
Well, David W2LNX, thank you so much for really interesting and exciting experiment results.
Right.
Any last words?
Oh, one of the things. So this is long haul. We need to figure out how to connect them to the HSMM mesh nodes with that run on Wi-Fi. So the Wi-Fi mesh network would be like the local area wireless network, and these would be long haul networks. So the question I have: can we create a super mesh network with these as the backbone? So mesh of meshes.
Backbone.
That's really the goal, because pipes are nice, but you got to pass traffic over them.
Great.
And you've addressed the fact that this can be integrated with our existing 802.11.
It's TCP/IP. It's Ethernet. The interface between routers is what? A piece of Cat5. That's the interface. So if you can configure them, and they can talk to each other, and you can learn how to do routing tables, you can create you can do all that.
Terrific.
And I'm learning how to do that, and I like the kid, you know. The nice thing about ham radio, you can learn about all the stuff in the gutter, so to speak.
Right.
You know.
Right. Okay. Well, thank you very much.
Oh yeah. So.